This is an automatic watering timer that I bought from Lidl about 1.5 years ago. It served me pretty well last year, kept my greenhouse watered, but this year it's become unreliable. So today we're going to open it up and see what's inside. So yeah, this only cost £12.99, so not really sure how much quality you can really expect, but this was a reliable water timer. It's got lots of features and functions. I've made a video about this, reviewing it. This year it became unreliable, and sometimes you'd hear a little click, but the water would not turn on. So I'm going to open it up. So my objective for opening this up is multifaceted. For one thing, I just want to have a look and see, out of curiosity, what's inside of this thing. Didn't want to do that when it was brand new. Obviously not a great idea always necessarily to tear down brand new items. But I also am interested today as to see whether we can figure out how this thing works, whether we can maybe see what the cause of the problem was, and see if it's repairable, see if the components inside here are reusable or recyclable, all of those sorts of things. So just want to know really what this thing is inside, what's gone wrong, and what we can maybe do about it. Okay, that's interesting. So it's divided into 2 modules. Really interesting actually. So we've got power lines here coming from the battery with, is that silicone? It's some sort of hard, semi-hard resin there, hard silicone. And then we've got control wires going off to presumably a switch unit inside there. That's actually really interesting because that means that this timer unit, which of course won't switch on now because I've taken the batteries out, this timer unit could be used independently of the solenoid switch or whatever is the mode of switch in here. So there are, I think, 4 screws to take this casing off of here. 2 of them are very deeply set inside those recesses there. I haven't got an extension thing that will go down inside of that tube. So, okay, one moment please. Okay, let's try that again, shall we? Right, let's keep these screws all separate. Those are the 2 screws from the outer case. This is not bad design, got to say here actually. There's a compartmentalised design here. So the wet part, the part that's under pressure, because this is on a tap and then you turn the tap on. So this part's under mains water pressure. That part is isolated from the bit that has all the electronics gubbins in it. That's pretty good design, in my amateur opinion. And then there's another one down all here. Even this screwdriver is not quite the right fit for that hole. Okay, that's that one out. And that's that one out. Right, now we need to be a little bit careful because we've got some rather delicate wires that go through the casing here. There must be some screws hidden under that sticker, I reckon, or something, because I don't see any on here. Right, I'm going to cut these wires now just so I can have this all apart. They're not, as far as I can tell, polarized, so I'm just going to assume. So anyway, there we go. There is a thing that could be attached to something else. And okay, it's got water themed iconography on it, but that's just basically a configurable timer that I presume it just applies 3 volts DC to that pair of wires. We will maybe take this off and have a look inside of here as well, but I'm not expecting that the circuitry will be especially complex. I think it will just be a epoxy blob with a custom chip underneath it, and then the circuitry to drive the LCD, maybe a step up or something like that in there. This is the bit that does the switching of the water. This is the solenoid unit. Well, I was expecting to find a screw under there. Not today. So how does this bit open? I have a feeling this might be sonic welded shut. Let's... Ooh, yeah, I don't think that's going to come open all that easily at all. And it is, that does appear to be the parting line there. This is not a little panel that pops out, I don't think. Oh no, hang on, I tell a lie. Look, I can see 4 more, what am I talking about? There are 4 more screw holes. Thank you for those of you that were yelling at the screen. I heard you. The screws are all the same. That's fine. So let's get that open. Now these little blobs of silicone sealant have come unseated from where they were. I don't want to strain those wires any more than absolutely necessary. So there we go, just pull them through there. So that bit of casing comes off, nothing to see inside there. And here is the valve. So I wonder if I can just do it with one battery. Right, I haven't stripped the insulation off of these wires, but of course the ends of the copper will be exposed. So let's just see if might not be enough voltage. No. Okay, so there's a little coil there. I assume that's going to pull up a kind of plug out of there, which is going to allow the water to flow. This is probably the point of no return now, where further disassembly will pretty much guarantee I won't be able to put this back together, but we'll see. Just going a little bit carefully. I haven't seen any signs of leakage or anything at the moment. Haven't seen any evidence that anything has particularly gone wrong. But of course this is a device where the moving parts have been in contact with mains pressure water for a period of time, which is going to mean all kinds of things may have changed in here. That's a little clip there. This fits inside of a bunch of plastic clips by the look of it. It really doesn't want to come apart. I suspect there might be some glue here. In fact, I think I can feel glue there. Right, so going in here. I've bent my spudger. I mean, I could take those screws off of there, but, well, let's see what happens if we do. Those don't appear to be part of the thing that joins this casing together, but we might get access to the little plunger or the actuator here. Now those 2 screws there are a different size. Ping, something went ping and is now lost and is now found. Okay, I can see a plunger there, and it moves. So this, there was a little bit of movement there. I can also see rust here, which might well account for why we have problems. I'm going to get a stronger magnet and see if I can pull that out. So this is a magnet from an old hard drive. Yep, so there's a little, wow, there's not much to it, is there? I think that might be is that just a magnet? No. So that's not a magnet, that's just a little steel plug. And does that then press on? Oh, I don't know. I wonder if that's just a little bit of steel that is there to concentrate the magnetic field lines or something. Well, I suppose actually one thing we can do here is take these pieces off now. I don't think it actually unscrews from the top there. I think that's a free running. Yeah, I don't think that's actually a thing. It's probably clipped on in some way. Well, disappointment. But yeah, the fact that there's rust on this bit, which is actually would have been on the outside of the water path, suggests to me that maybe there is a problem here that's just been caused by a very slight leakage, maybe just accumulation of condensation or something like that over time, and perhaps the critical moving part inside of here is also rusty, and that rust has caused it to no longer be a free running fit inside its little channel. Anyway, right, well, I'm going to go off and do a little bit of research and stuff about this and see if there's any way to get that open, see if anybody else has maybe done a teardown. But that does appear to be glued in addition to the screws. So I think we might be at the limit of what we can do with this thing. Maybe this solenoid thing is a standard part though, so maybe we can find another one of these. Before all of that though, I think we will have a look inside this timer unit. We'll just get these screws off. Rather large number of screws around the outside here. They obviously wanted this bit to stay shut. These screws are different, so they look to be the same diameter or thread, but they're longer and they're pointy. So yeah, I can see that I could possibly use this this timer unit for some other purpose. For example, what we could do here is if I had a project that ran using say a Raspberry Pi Zero that needed to conserve battery, and so I didn't want it powered on all the time. I just wanted to power on for maybe 2 minutes, do a thing, then power down, and do that on a schedule. I could use this unit to do that external scheduling so that we end up with completely isolating the power from the thing, except for the little 2-minute intervals when it powers up, does its thing, shuts down again. So that's just kind of one way that a general purpose timer controller that this appears to be, albeit, as I say, the display and stuff, it has a watery theme, but it is just a programmable timer that switches a thing on and off according to a program. I'm having problems with that last screw. Let's just go for that. Okay. Now, it's ever so slightly interesting that there is a bulge here in this casing, so that might mean something or nothing. Why is that not coming out? Oh, because it's got a knob on it. Is the knob... Do we have to pull the knob off? Yes, we do. And then that can pop through the case. Well, how about that? Wow. Construction on this is significantly better than I expected. I really thought we were going to be looking at a little transparent panel glued into there, and that this was going to be just a bare circuit board. But it continues to surprise me. Is it going to come apart? Is there another screw somewhere? So there's a screw, 2 screws there securing the circuit board to the front of the case. It feels like, oh, it might just be the cables. It's where this got this blob of sealant on here. I wonder if I can get that off without jeopardizing the wiring. I suppose even if I have to cut these wires, their positions on the circuit board will be fairly obvious. So it shouldn't be impossible to get it back together again and, you know, figure out where the power and the data actually is. Is that going to come apart now? Yes, I think so. Okay, so again, surprises. So we've got a little microcontroller there and pins breaking out to the LCD display. That's a little oscillator crystal there, I think. Various capacitors. These are going to be MOSFETs, I think, that drive the solenoid. Do you know what? It's actually pretty good stuff in here, really. It seems like a really well-built circuit. Interesting that there are some things that are not populated. There's a little pin header there. I wonder if that's a programming header for the microcontroller. Wow, really interesting. Now, I'm not Big Clive, so I'm not going to try to reverse engineer this circuit for you, but I will take a close-up picture of it, and I'll show you that on the screen now. So this controller chip here has some markings on it. I will try to see those. Really tiny text, and my eyes are not what they used to be. It says T431 3A161101. If I can get anything out of Google for that, it'll be on your screen right now. And then there are these 4 screws which secure this board to the front of this clear case. So we'll just have those out so that I can take a picture of the other side of the board. Now the LCD display panel is attached to this board via quite a robust method. I'm not used to seeing this. So if you take a calculator apart, very often the LCD panel will be attached to the main board by a kind of silicone ribbon cable jelly thing that is incredibly fragile and only works when it's kind of pressed together. This is not that. This is a discrete LCD module, glass LCD module, and it's got solder pins on there. I mean, considering this whole thing was, as I say, $12.99, this is remarkably well engineered. I did actually also notice that these little headers here say VDD, ground, VPP, SCK and SDA. SDA and SCK is a serial connection, a serial port connection. If we could, we could hook this up to a terminal and, in theory, get some serial data out of this, or maybe actually even reprogram it, although I'm not quite sure what we would reprogram it to do that's beyond the scope of the wide range of functions it already has. So anyway, I'm going to put this back together now, at least partly. But yeah, I'm just thoroughly impressed with the engineering of this thing. But Mr. Shrimp, how can you be impressed with it when it went wrong? I suppose that is a good point. It did go wrong, but you know, I mean, what more could we have really expected from the insides of this thing than what we've seen? It does look like perhaps this solenoid is the weak link in the chain, and perhaps there will always be a weak link in a chain when you want an electronic device to sit outdoors for half the year in all weathers, turning the tap on and off. It may just be that expecting that from a small electronic device is just always going to be an equation that results in fairly early failure. But like I say, the effort that's gone into the engineering of this thing, you know, this went wrong, but it's not for want of trying. These are, I think, self-tapping screws. Yes, they are. When you're screwing self-tapping screws into plastic after disassembling something, this is a tip I've said more than once in the past, but I'll repeat it again now. Always a good idea to turn it anti-clockwise until you feel or hear a little click. So let's just do that again. That means it's found its thread. It's found the original thread that it was driven into. Then turn it clockwise, and that way you're not cutting a fresh thread in that plastic. Let's just do that again. So we turn it anti-clockwise, counterclockwise if you're American, until you hear a click, then go forward clockwise. Right, that's those. Then that goes back onto there, and then a few more screws go in. So there we go, and then I could put that back together somehow like that, and I've got my relatively self-contained little widget with a battery compartment, and there is room for me to squeeze a Raspberry Pi Zero in there or something like that if I had to. Maybe if I was a 3D printing nerd, I would 3D print a new back casing for this that housed whatever project I want to put on there. But that's useful. Let's put this back on. There we go. So anyway, useful bit of gubbins. I will store that away somewhere. I'll probably use it. I'm tempted to actually get on and do a project on that sooner rather than later before I lose the impetus. But yeah, thoroughly impressed with the kind of the quality detail in there. So it's been a bit of a Parkside double bill on videos for this weekend, because yesterday's scam video had a scam that was pretending to be the Parkside website. Oh, by the way, also thank you to the people who let me know in the comments that sunlight, or actually natural light including ultraviolet, is not good for LCD displays. So you can see there's actually a tape mark on here where I had a flap of, I stuck some duct tape to itself and left one little bit sticky, put that on there and had a flap of that over the display to protect it from degradation from ultraviolet light, and that worked. That part didn't fail. That tape is now on the new unit that I've got out in the garden, which is functioning okay, but what kind of lifetime can we expect from that one, I wonder? Just a couple more things before we wrap up. I believe this is a pressure actuated solenoid valve. So I think the way this works is this solenoid, which is quite small, opens a tiny channel and allows a tiny little bit of water to flow through. The flow of that water turns something, pushes something, moves something, and the mechanical work done by that small amount of water flowing is the thing that then drives the thing to open the main flow. That being the case, and me living in a hard water area, it's probably quite likely that that small channel has just furred up. There isn't any sign of limescale anywhere on it, except maybe on that filter there, but I think that might be what's gone wrong. That channel has become constricted, because one thing I did find is that this pump would work reliably if I didn't attach the hose to it, but if it's got anything that impedes the flow at all, would tend to make it less reliable. So that's that, and we may find that that's the same problem with the new unit that I've replaced it with. It might be just that I can't get anything that's going to give me a long-term solution. I do also tend to think that these things don't fail in service, they fail in storage. So what's probably happened here is that this would have carried on going for a lot longer if I hadn't detached it from the watering system and stored it over winter. But of course I couldn't leave it going anyway, or else it would have frozen up. Anyway, there is also one more thing I want to do before we're done, which is to just find out what the output of this is when the timer triggers. So I'm not Big Clive, I'm not any kind of Clive, but I think we can probably measure to see if there's a voltage across this when it triggers, and see if it's a momentary voltage or if it's held until the, for the duration of the timed event. Somewhere I've got some clip probes for this multimeter, but I don't know where they are. These are enamelled copper wires here, so I'm just going to scrape down to the copper on both of those. Sandpaper would be better, but I haven't got any to hand. Then I also need to install batteries. A little bit of electrical tape, and I will just make sure again that the uppermost surface on this wire is bare. So there we go, that's the two probes. Can we see all of the displays? Yes. Right, so I'm just going to put it on the override timer, which is press and hold that, and then, well, there should have been something there. Well, I wonder if it only sends a pulse. Doesn't actually seem to have sent anything there. That's interesting. Well, that's a puzzle, isn't it? So maybe this thing only sends a tiny pulse, like one polarity to open the solenoid valve, and then the reverse polarity to close it. Maybe it does it that way. And yeah, we're getting nothing. And it is still running. Okay, well, a little bit more detailed research required there before we decide to actually do something with that, because it might be that I have to adapt that circuitry a bit more than I thought, but I'm sure the potential is there. But there we go, that is the teardown of the Parkside automatic watering system. It does look like it's got hackable potential. I hope that's been interesting. Thanks for watching, and I hope to see you again soon.